Hi everyone. So welcome to Design and Analysis web series. I have posted so many concepts related to design and analysis algorithm like recursive and non-recursive algorithm, greedy algorithm, dynamic and so on. So if you want to know more about this, kindly subscribe and follow. Hi everyone. Welcome back to DAS series. Today we are going to see the another concept, chained matrix multiplication under the dynamic programming. First we shall see what is meant by matrix multiplication. We shall take an ordinary matrix. Consider A matrix which contain 3 column and 2 row. This contain A matrix contain 2 row and 3 column. Similarly, consider another matrix. So this contain 3 row, 2 column we can have 2 column. So 2 column. So why I have written 1 1 na, that is the representation of this position. First row, first column. First row, second column. Likewise, their position I have represented. That's why I have written B11, B21 likewise. Here we need to represent the row and column. The first one comes the row and the second one comes the column. There is one rule such that the A matrix column and the B matrix row should be same. Then only we are able to find the multiplication for both the matrix. So this is one rule we know. What will be the resultant and the total multiplication? So the resultant matrix is nothing but 2 cross 2. This is this row and this column. That kind of row column combination result only we will be getting as a C matrix. Similarly, if you want to find out the total number of multiplication, so how many total number of multiplication? So how we will add or multiply the matrix? Na? First row and the first column should be multiplied. A11 star B11 plus A11 star 21. Likewise, we need to do the multiplication. So the total number of multiplications can be carried out with the help of this 2 into 3 into 2. Na? Likewise, 2 into 3 into 2. So total number of multiplication is 2. So likewise, we can identify how many total number of multiplications can be done for each matrix. So this is a matrix multiplication. What is a chained matrix multiplication? Chained matrix multiplication is nothing but we can take a continuous matrix A1, A2, A3 and goes on. And we perform the multiplication for these matrices and that is said to be the chained matrix multiplication. Suppose if we take row comma column and this should be same with this one. Both of them should be same. And similarly this 4 and 4 should be same with this one. We shall take or consider this one as D0 and these two both can be considered as D1. This 2 can be considered as D2 and this can be considered as D3. So why I made it as a common? Na? Definitely this column and this row should be same. Therefore, I have made it as a D1 with the total combination. Okay, na? So I made it as a combination. Likewise, how many combinations we can have? We can find it out using through the formula 2NCN divided by n plus 1. Suppose if we have 4 matrix, then n should be considered as a 3. So n should be considered as a 3. Therefore, n can be applied with the value of 3 and we will be getting 6C3 divided by 4. So 6 into 5 into 4 divided by 3 into 2 into 1 divided by 4. So totally how many combinations? Na? N is equal to 4 means 5 possible combination. N is equal to 4 means 5 possible. Similarly, n is equal to 5 means 14 possible combination. 14 possible combination we will have. What I'm saying, what is the combination I'm saying? What kind of combination I'm saying? Na? If you are taking any this chained matrix A1, A2, A3, we can multiply either A1, A2 first, then A3, or we can multiply A2, A3, then we can multiply A1. Likewise, we can do. Suppose if we take 2 cross 3 and this is 3 cross 4, and definitely this should be 4 cross 2. Likewise, 2 cross 3, 3 cross 4, 4 cross 2. So what is the problem they are trying to say? We need to find the total number of multiplication. How many total number of multiplications they are doing. So first we are multiplying these two. So 2 into 3 into 4. That is equal to 24 multiplication for this one. Resultant matrix is 2 cross 4. And that should be multiplied with 4 cross 2. So what is the total number of multiplication? 2 into 4 into 2. That is 16. So 24 plus 16 is equal to 40. So when we take this kind of combination, we are getting the 40 multiplication. We shall check it out with this combination. First we need to multiply these two. So we will get 3 into 4 into 2. 3 into. So that is 24. What is the resultant matrix? 3 into 2. That should be multiplied with 2 into 3. So 2 into 3 into 2. How much? 12. So 24 plus 12. So 24 plus 12, 36. So 36 total number of multiplication. Same thing. These are satisfying the associative property, and therefore we will get the same result. The result will be same for both the combination. But this is having the less number of multiplication. So we need to identify who is having the less number of multiplication. If the matrix is n is equal to 4, we have 5 possible combination. N is equal to 5, we have 14 possible combination. So for each combination, we are not able to find out the total number of multiplication. So here we have one formula to find out the total number of multiplications for each combination. Dynamic programming is nothing but we need to find the all combination, and therefore through that formula we can find out the what kind of which kind of combinations is having the minimum number of multiplication. So that can be done with the help of this one. So what we are doing, we are simply taking one of the combination. In this combination we can have this 3 cross 4, 4 cross 2. This should be same, na? So this is nothing but D0, D1, D2, this is, and this is D3. This is D3. So what we are doing, just we are multiplying the C, that is 1 comma 2. 1 comma 2 means is nothing but first matrix and the second matrix. It's multiplied. So when this multiplication is done, what the remaining third matrix is done? 3 comma 3. 3 comma 3 is nothing but here we are having total number of 24 multiplication. Here we are not doing any multiplication. Simply 3 comma 3 is brought simply down. We are not doing any of the multiplication. So just we are adding with it. After that what we'll do? This. So here we will continue. This multiplications what we are getting here, 2 cross 3 and 3 cross 4. That is nothing but we are multiplying the first matrix and the second matrix, and total number of multiplication is 24. When we do this 2 into 3 into 4, so total number is 24. Here we do not we don't do any of the multiplication, so we get 0. Similarly, at last what we have, 4 cross 2, 4 cross 2, this is A3, and after multiplying this we get 2 cross 4. that is 2 into 3 into 4, this matrix. So next we need to multiply with this 2 cross 4 into 4 cross 4, and at last we get 2 cross 2. These two are multiplications of first combination. Then we need to do addition and multiplication with these three things. These three things is nothing but 2, 4, 2 is nothing but this 2 is D0 into this 4 is nothing but D2, and this 2 is nothing but this is D3. So D0, D2, D3. This 4 is D. So here totally we have C of 1, 2, C of 3, 3 plus D0 into D2 into D3. So here what is the matrix? C of 1, 3. I, j is nothing but equal to. Okay, when we multiply 1, 3, we are getting this. Similarly, suppose if you take 1, 3 with some other combination, consider I, j is 1, 3. We need to multiply this matrix. We may get C of 1, 1 plus C of 2, 3, 3 plus this combination I am writing. So D0 into D1 into D3, which is this combination, this 2, 3, that dimensions we are getting. So in general, how we can write the general formula? Suppose I, j, what we are having? 1, 3. So here 1, 3. So same thing, suppose if you are going for the different combinations, we are getting the different. So this I will be the same, 1, 1. So we can write this as I. But here we have 2. So here we are having 2. Here we are having 1. Therefore this is somewhat different. So we need to go with the different variable. Plus C of. Here we are having the different. Here we are having 3, here we are having 2. Which means this k can be incremented. If it is 2, it is 3. If it is 1, it is 2. So we can write it in general as k plus 1. This 3 is nothing but this j. So C of this 3. So this can be written in general as a j. Plus, already we know that this combination 2, 4, 2 na D0. Okay, that is nothing but di minus. In general we can represent this I minus 1 into this k na, so k into dj I minus. So this is a general formula which help us to find the total number of combination whatever the matrix is given. So n is equal to 4 matrix, n is equal to 5 matrix, whatever the matrix is given, by using this formula we can find the final combination and final total number of multiplication. So in next video we shall take one of the chained matrix and we shall solve that one using this formula. Okay, thank you.